So the concept behind inverses. The reason why we have inverses primarily is because we cannot divide matrices. However, inverses are severely limited. You can only create inverses out of square matrices. So if you want to sort of consider division, that would mean that you could only divide by square matrices. You can't do that to all matrices. Also, you can only create inverses only exist. So here, let's back up a little bit. First of all, in order to show an inverse, we use a little -1. That means inverse. So that's the inverse of matrix A. And A has to be square. Sorry, I got excited and started going way too fast without writing anything down. Where is A? Yeah, that doesn't make any sense. Where it is, I don't know, where A is, where A is a square matrix. Okay, it also only exists if the determinant is not equal to 0. And I'll explain that a little bit here in just a second whenever I kind of give you. It'll make more sense when we go to the definition of a 2 by 2. Okay, so that's kind of a definition of an inverse. So the point of having an inverse is wherever I take an inverse matrix times a normal matrix, I get the identity. Remember, identity is kind of like the number 1 in the world of matrices. So wherever I take a number divided by itself, I get 1 back. In matrices, wherever I take a matrix times its inverse, I get 1 back. And remember, matrices are, the commutative rule does not work, but whenever you're working with matrices or inverses, it does. So it doesn't matter which side I multiply it on. I feel like I wanted to say something else here, but maybe I didn't. I left an awful lot of space just to say that. I is your identity matrix. I is the one where you have 1s down the diagonal and 0s every place else. It acts like the number 1. So if I take any matrix times the same size identity matrix, I will always get that matrix back. So 1, 2 times 1, 0 will give me 1. 1, 2 times 0, 1 would give me 2. 3, 4 times 1, 0 would give me 3. 3, 4 times 0, 1 would give me 4. I is always squared, so if I had something like a 2 by 1, and I wanted to multiply it by 1, I would just pick the appropriate sized I, which would just be 1. If I had a matrix like this, the appropriate sized I would be a 3 by 3. Whatever works as far as the multiplication goes. Okay, so that's kind of the concept behind the inverse. So now we have to talk about how to find inverses. The 2 by 2 inverse, there's kind of a shortcut way of doing it. So let's say that we had matrix A that looks like this. A, B, I don't know why I wrote it like that. Let's go back, sorry. A, B, C, D. Then the inverse would look like this. Okay, I take these two numbers and I switch their places. I take these two numbers and I switch their signs. You might think, well, how is that a shortcut? Trust me, it's a shortcut. And then you divide by the determinant of the original matrix. It really doesn't matter which determinant you divide by because the determinant of those two matrices is the same. So that's your rule for finding the inverse of a 2 by 2. So if I find the inverse of this matrix, what I want to do is I want to take the 3 and 4 and they switch places. So now I have 4, 3. I change the sign of each of these numbers. So the 2 now becomes a negative 2. The negative 1 now becomes a positive 1. And I take that entire matrix and I divide it by the determinant. Now remember, to find the determinant, that's where we cross multiply and divide. Or cross multiply and subtract, sorry. So I take 3 times 4 minus 2 times negative 1. So that'd be 14.
Wait, did you do the determinant of the inverse?
It honestly doesn't matter. Either way, it'll end up being 14. Because if I do this one, it still ends up being 12 minus negative 2. So then my inverse is 2/7, negative 1/7, 1/14, and 3/14. So that's the inverse of A. Okay, so how about the inverse of B? Okay, so the inverse B actually doesn't exist. This is why the determinant cannot equal 0. Because the determinant is the number that you divide by, so if the determinant is 0, you're dividing by 0, which is not possible. So, since the determinant of B is 0, B inverse doesn't exist. Okay, now, I'm going to show you why this is a shortcut. Because we're going to find the inverse of a 3 by 3. I may ask you to do this. I don't remember if I asked you to do this on homework or not. I will not ask you to do this on the test because this is way too time consuming. This is really good practice of your row operations though. So, what I'm going to do, here's the concept. Concept is, we're going to make an augmented matrix. Over here, we're going to put matrix C. Over here, we're going to put the identity. Through row operations, we are going to change the left-hand side into the identity matrix. After we have done that, the right-hand side will be the inverse of C. So we are going to use row operations to change this matrix into this matrix. We're going to take and we're going to change C into the identity matrix by changing, all those numbers into zeros, just like what we did in 8.1. It's just we're going to move farther. We're going to change everything into zeros. Once that's done, and then we'll do some dividing and change the middle diagonal into ones if they're not already ones. After we've done all that, then what is left over here is the inverse of C. Okay, so we're going to start by changing this into an augmented matrix. So 1, 2, 2, 3, 7, 9, -1, -4, -7, 1, 0, 0, 0, 1, 0, 0, 0, 1. So on the left-hand side, I have C. On the right-hand side, I have the identity. I am done once the left-hand side is the identity. Okay, this first step, I'm going to leave the top row alone. But I'm going to turn these first two into zeros. So, just like we did in 8.1. What do I need to multiply the top row by and add to the second row to turn that 3 into a 0? So this is like having x and this is 3x. So how do I cancel out my x's? -3. So -3 times row 1 plus row 2, and I'll put that inside of row 2. So that would be -3 plus 3, -6 plus 7, -6 plus 9. And then I keep going. -3 plus 0, 0 plus 1, 0 plus 0. Okay, just to save space, I'm going to go ahead and do the bottom row also. So what do I need to do to get 1 and -1 to turn into 0? Just add them. So I'm going to take row 1 plus row 3 and replace row 3. So 1 plus negative 1 is 0. 2 plus negative 4 is negative 2. 2 plus negative 7 is negative 5. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. Okay, my second step, I'm going to leave the second row alone. Okay, but I have to turn this whole thing into the identity matrix. So now instead of just changing this into a 0, I also have to change this into a 0. So I'm going to use this number right here to change both the top one and the bottom one. So what do I need to do to this 1 to change this top 2 into a 0? Multiply by a negative 2. So I'm going to take negative 2 times row 2 plus row 1, and I'm going to put that inside of row 1. Now, since this first number is 0, I no longer will affect this first number up here, which is what I want. So, I have 0 plus 1 is 1. Negative 2 plus 2 is 0. Negative 6 plus 2 is negative 4. 6 plus 1 is 7. Negative 2 plus 0 is negative 2. And 0 plus 0 is 0. Okay, how about row 3? What do I need to do? Multiply by positive 2. So 2 times row 2 plus row 3. I'm going to put that inside row 3. So 0 and 0. 2 and negative 2. 6 and negative 5. Negative 6 and 1. 2 and 0. 0 and 1. Yeah. Okay, my last step, I'm going to leave this bottom row alone. And I need to get rid of that 3 and that negative 4. So if I get rid of that negative 4, what do I need to multiply the bottom row by? 4. So 4 times row 3 plus row 1 equals row 1. So 0 plus 1 is 1. 0 plus 0 is 0. 4 plus negative 4 is 0. Negative 20 plus 7 is negative 13. 8 plus negative 2 is 6. 4 plus 0 is 4. Okay, to get rid of that 3, I'm going to multiply by negative 3. Okay, so 0 plus 0, 0 plus 1, negative 3 plus 3, 15 plus negative 3, negative 6 plus 1, negative 3 plus 0. Now, over here, this is now the identity. The only step you might have left is if one of these numbers is not a 1, you might have to divide by something. So like if this number here was a 6, I would take this row divided by 6. So I would end up with 2, negative 5, 6, and negative 1 half. Since these are all 1s, I'm done. So this is the identity. This over here is C inverse. Now do you see how the 2 by 2 has a shortcut?
Yeah, I didn't like
It's, I don't know, it's not difficult, it's time consuming.
I didn't understand it, so. I didn't understand
That's Josh is coasting. I said you're coasting right now. Okay. Again, this, I want you to see it. I might give you a problem or two on your homework. This is not on the test. This is too time consuming to put on the test. The most you would have on the test with the row operations is like 8.1. Okay, solving systems. This is the goal. This is why we do inverses. What we do is we take a system of equations and we turn them into matrices. So we make it look like this. A is your coefficients. This is your variables. So this is a matrix that looks like this. And then these are your numbers on your other side. So that'll be your two numbers. Your coefficient matrix is a 2 by 2 with your coefficients. Now, you can do this with bigger systems. We're only going to do 2 by 2s. So the concept, if we solve this algebraically, I have my system that looks like this. I want to solve for x. How do I do that? So I want to get to x by itself. Okay, but we can't divide because these are matrices. Times the inverse. Now, you have to be careful because remember, the commutative rule does not work. So, in order to multiply a by its inverse, it has to be on the left-hand side. Since this is on the left-hand side, this also has to be on the left-hand side. That's very important. Because if you put it on the right-hand side, for one, that multiplication does not work. But even if the multiplication did work, you would get the incorrect answers. Okay, so this here turns into the identity matrix. So that just tells me that x equals A inverse B. So then that will tell you what your x and your y are. So this is what we need. We've just solved our system of equations. We just have to take A inverse times B. You mean square matrices? It has to be a square matrix in order to get the inverse. Okay, so if I'm doing this, I change it into my augmented matrices, or not augmented, sorry, into my system of matrices. Nothing here is augmented. So there's my coefficients. I put the x coefficients and the y coefficients in columns. Times my variables. If you did that multiplication, you would get your equation back, right? Row times column. So 3 times x plus 5 times y equals -2. That's my equation back. If I take the second row, 4 times x plus -1 times y equals 7. There's my second equation. So that's why we can write it like this. It still equals our equations. Okay, so according to what we just figured out, we can solve it by doing this. We just need to figure out what A inverse is. So A inverse, we take this matrix, we swap the -1 and the 3, and we change the signs on the 5 and the 4. And we divide by the determinant. So here, over here, let me find the determinant of the A. So determinant of A is 3 times -1 minus 4 times 5. So that's 3, or -3 minus 20, so that's -23. Now, I don't know about you, but I do not want to do multiplications with 1/23 and 5/23 and 4/23 and 3/23. So what I'm going to do is I'm going to use this matrix like this. Because according to one of our rules, with a scalar multiple, which is what this is, it doesn't matter whenever I multiply it. I can wait until the very end. So that's what I'm going to do. I'm going to do my matrix multiplication, then I will divide by that 23. So then I don't have to deal with any fractions. So x equals -1/23 times -1, -5, -4, 3 times -2, 7. Okay, so that equals -1/23. Okay, I do my multiplication, so row times column. So -1 times -2 plus -5 times 7. So 2 plus -35 is going to be -33. And then my other multiplication is -4 times -2 plus 3 times 7. So 8 plus 21 is 29. So that means I get 33/23 and -29/23. Remember, x is equal to this. So that means that x is 33/23 and y is -29/23. Now, I did way more writing than what I would have to do. You guys can probably do most of that in your head. I just wanted to make sure I wrote out every step. Do you want me to do another example of that, or are you good? I feel your silence means another example. Huh? Do you want me to do another example? Yeah. No. The 5 and 4 just switch signs. Okay, let me do one more. Okay, so determinant of A, I cross multiply. So it would be 4 minus negative 40. So determinant of A would be 44. You okay with that? Okay, so inverse of A would be 1 over 44 times, switch the 4 and the 1, and change the signs on the 5 and the negative 8. So that would be negative 5 and 8. So then my answer is I take that times B. So 4 times 13 is 52 plus 5. So that'd be 57. 8 times 13 is 104 plus negative 1. So that's 103. So that means X is 57 over 44 and Y is 103 over 44. So that's my hope for how quickly you can do those. Let me make sure of that real quick because yeah, that should be fine.